We're delighted to have today our colleague from Dow, Sarah Eckersley, who's going to talk to us about artificial intelligence. And obviously, this is the topic that is now, I think, a hot subject in discussions in absolutely all industries and sectors across the board. And it's really great to know that the chemical industry has been doing great strides already for years to implement artificial intelligence in our work. So, Sarah, would you tell us more about how you use AI efficiently in your product and process design in Dow?
Absolutely. Hello, everybody. And thank you to Cefic for the invitation to participate in this important dialogue. I'd like to start by just introducing myself briefly. I have responsibility for research and development for a business group at Dow. And I also have done a lot of work over the past 5 years or so around digital approaches to accelerate adoption of technology at customers. So my topic today is focusing around the utility of AI in bringing new innovations to market, and with a particular emphasis on new sustainable innovations. I think that we have a real opportunity in the chemical industry to embrace the potential of data and digital technologies to innovate new and sustainable chemistries and products. Moving on. So I'd like to emphasize the word new when it comes to sustainable solutions. So in order to bring new solutions forward, almost by definition, we are going to be doing things that are new. New chemistry, new processes, and as was just mentioned, this will include new value chain collaborations. And when we do something new, there is an intensity of investment and work that's required, because bringing new things forward is complex in its execution and the work involved. Just to give an example of what that looks like doing our more traditional mode of innovation. If we are in our traditional research and innovation processes, it would typically take something on the order of 10 years or so to bring a new chemistry platform from the time when we first invent and reduce to practice in the lab through the time that we've actually scaled it up fully to be able to be supplying those materials at scale. Even the most simple products that you see around you have a great deal of complexity in their design and execution. And I'm going to talk in a few minutes about the example of decorative paints, which everybody will likely have on the wall in the room that they're sitting in. Just what seems on the surface to be a simple product like that easily takes 2 years and a lot of data to bring to market. And then a third example would be implementing polyurethane chemistry in in insulating panels in commercial buildings. Just to actually go online and collect the data during the fabrication process of those panels, we might collect over 30,000 data points and be monitoring and adjusting 50 variables. And so even in, let's call it the old traditional mode of bringing products to market, there is a tremendous investment in data. And that data is incredibly valuable because at the end of the day, it allows us to make the right decisions to bring safe and effective products to market. Next, please. So because that data has so much value, inspired organizations are really investing to harness that data richness to turn it into knowledge wealth. And I'd like to use the example of a predictive capability that we've developed in Dow's polyurethanes business called Predictive Intelligence. Polyurethane chemistry is something that we've been practicing for decades. We have a great deal of experience formulating custom polyurethane solutions that are used by customers in their products. things like that insulation that I mentioned, or bedding, or the interior of a car seat, for example. So once the products are in the final form, they look fairly simple and straightforward, but there's actually a lot of very complex chemistry and engineering that's going on in those products. The chemistry is a reactive chemistry, so it's a multi-component complex chemistry. When the chemistry is being used, it often undergoes foaming, and at the same time you might be filling a mold, for example. So lots of complex things going on. And because we have such a data-rich environment, we created Predictive Intelligence by integrating the lab data, chemistry fundamentals, process models, our own scientists' expertise, which remains critically important, and combined it all into a predictive model, which can ultimately give you provide our customers with a starting point formulation in seconds of digital modeling. So we can focus all of that data power into a single customer interaction to design a product that's tailored for them, with obviously increased speed to market. But as noted in the Cefic report, harnessing that data richness is actually a really challenging and intensive journey. You have to do many things in order to get to the point where you can actually do AI and do prediction. You have to acquire all that data from all of the labs around the world and harmonize it between different teams that may not be doing things exactly the same way, using exactly the same methods. You have to structure that data so that it can be used for modeling, and sometimes that data comes from disparate sources. And ultimately, you need to implement new processes and new ways of working that change the way people work, and requires change management, and it also requires new digital skills, as was also highlighted in the report. But the result is well worth the journey, because it gives us tools that transform the way we work and can collapse the timeline to develop new product solutions. And ultimately, the opportunity to apply those tools for urgent sustainability programs. Next slide, please. I'd like to talk about 4 programs from Dow that I think really exemplify the potential of digital to deliver sustainable outcomes. Some of these programs are very well developed, and others are still under development. And I think that this illustrates just how fast moving this opportunity space is. I'd like to start with the example of Paint Vision, which was developed by our coatings business and is an online tool for formulating paints and coatings. And it can be used by formulators of all skill levels, and actually around the world. We've launched it in all geographies. It may not be obvious on the surface, but even the simplest paint, even the simplest decorative paint or coating, could contain up to 15 ingredients or more, each having a very specific function in the paint. One of the major ingredients that a paint contains is a white pigment called titanium dioxide. This is used to make the paint opaque. So the reason your paint is white is because it contains titanium dioxide. It also happens to be one of the highest carbon footprint ingredients in a paint or coating. So there's a driver to replace at least part of that titanium dioxide with alternatives. And we do this with a material called opaque polymer. And as part of the Paint Vision platform, we've developed a tool called Optionizer, which allows the formulator to design paint formulations both for properties, for performance properties, and for cost, but also for carbon footprint reduction. So by replacing part of the TiO2, they can immediately and automatically calculate the carbon emission reduction of that paint that they've designed, and then they can go into the lab and reduce it to practice. The second example that I'd like to give is called Smart Search. When somebody is doing innovation and starting a new program, one of the things that they're often doing is new product innovation. And Smart Search helps them identify and prioritize compounds from the catalog of known chemicals, which is called the Chemical Abstracts Database. Chemical Abstracts Database contains over 250 million materials, and Smart Search allows for an intuitive search that searches on properties, chemical structures, hazard phrases, and whether or not the ingredient is commercially available. And it does this in seconds. And we've started to use Smart Search to help us in selecting starting materials for programs that are the most sustainable. And we've actually used this in looking for potential replacements of materials of concern. So we're very excited also by the fact that Smart Search won a CIO 100 award this year, and it also won an Edison Gold Award for AI optimized productivity. The third example that I'd like to use is a tool called Crop Solver, which is also an online tool that's used to accelerate the development of new agricultural chemicals. So customers can use advanced filters that helps them identify inert ingredients to create an agricultural formulation that's tailored to their specific needs. It's live in North America today. It's going to be available in Europe and Latin America later this year or early next year. And we're starting to add future version features to Crop Solver, which will allow the formulator to select also based on sustainability attributes. So a great example of this that we're adding soon is organics certified based on the USDA organics program. The last example that I'd like to come back to is predictive intelligence. So again, we're using this to do AI-enabled formulation design for polyurethane materials. And we're starting to deploy it to help with the adoption of circular Renuva polyols. These are polyols that are created by recycling end-of-life mattresses. So we would call them circular polyols. So they're based on the familiar polyurethane chemistry, but we come back to this topic of newness again. They're not exactly the same as all of the existing polyols, so they require new formulations. And with that comes the need for all of the data intensity that I described earlier. So we're building on the formulation models that we created with Predictive Intelligence to recommend formulations using the new Renuva circular polyols so that they can be taken into familiar polyurethane foam applications. So we can zoom into formulations that meet customer needs, model key property interactions, ultimately fine-tune those formulations and recommend starting points to our customers. So with Predictive Intelligence, we're extending the formulation space to allow the adoption of these circular materials, taking advantage of all that data investment that we made previously and those models that we created previously to speed up real-world sustainable solutions like Renuva. Next, please. So that concludes the comments that I have. I think that we have a tremendous opportunity to use AI to really accelerate the adoption of sustainable solutions, but we're still very early in that journey, and there's a lot of exciting work remaining to do. And thrilled to have Dow and colleagues who are on the phone be part of driving that journey. Thank you.